Welcome to a read along with Dr. Powell on the book Discrete Perspectives in Mathematics. This is section 5.2, Module Maps, introduced with an application. Okay, here's the first subsection. All right, a group isomorphism that helps solve systems of congruences. So in this section, we're going to be talking about one of the main goals of this section is to talk about systems of congruences. Okay, so let's take a look. All right. So kind of a system of congruence is something like this. So you have like x congruent to something, and it's also congruent to something else. Can you find a value of x that matches both of those criterion? So that's the type of system that we're going to be discussing how to do. And so here's like another one, and using these ideas, we're able to do systems even like this. And so, but in order to get there, that's what we're going to be looking at here. So first, we look at a group isomorphism that helps solve systems of congruences. So there's an isomorphism that's going to help us. I'm looking at two group tables here. This is Z mod 12Z, and this is Z mod 3Z cross Z mod 4Z. Now, these tables look about the same size, and in fact, they're the exact same. They're just labeled differently. 0 is labeled as 0, 0. And you look at each line, so there's a 0 here, 0 there. Let's see over here. There's 0 right there. Okay, now what about 1? 1 is kind of like the point 1, 1. Let's see. There's a 1, 1, 1, 1 there. Look, there's a 1 and a 1 here. The exact same addition table completely, but just labeled differently. In fact, the addition right here in this group, which is done component-wise, meaning like you add in like the first component in mod 3 arithmetic and the second component you add in mod 4 arithmetic. This group right here has the exact same structure and size as this one additively. So they're isomorphic, even though they look completely different. Like we're adding things like this together in one, and the other one we're adding things like this. But it does map over. Now here actually is a map that relates the two. If you say a blue bar, so blue is referring to mod 12 arithmetic, and so you take any representative in this fiber, and then you throw that representative under a red bar and under a green bar. That is the map. Just taking the same thing and throwing it under the different bars. So essentially, this is the map right here. 10 bar goes to 10 red bar, 10 green bar. And then the only difference that happens here is that we've just rewritten 10 red bar as 1 red bar because we're working in mod 3 arithmetic, and mod 4 arithmetic, it's 2 bar. So we have a nice, simple, easy relationship between this table, and this table given by this idea. This is an isomorphism because it's a bijection, and it preserves group structure because it preserves addition. Because really just throwing under another bar is like just modding out more, and modding out more than what you had before preserves addition, and then this is really addition here is just component wise anyhow. So it preserves addition, so it preserves the group operation and the group structure. And then since it's a bijection, we call it an isomorphism. An isomorphism is a bijection that preserves structure. Okay. So let's suppose we have a system that looks like this of congruences. X is congruent to 1 mod 3, X is congruent to 2 mod 4. You could have rewritten it like this. And then you want to figure out what value of X will give it to you. Well, pretty much you just have to reverse this isomorphism. So here in the actual equation, we have a 1 and 2 showing up, this 1 and 2. And we want to say, okay, we want to work backwards. What's that? Well, if we know what group this is isomorphic to, and we know how this map works and how it reverses, then it's simple to go back. And that's one of the points this section is to discuss how to reverse such a process, how to go backwards from here to there in this isomorphism. If I'm given a 0.12 here, so this you could think of this as all of these are like all the solutions of congruences, and then these are the congruences that they are solutions to. If you think about it, like x is congruent to 1 mod 3 and congruent to 3 mod 4. What's the solution of that congruence? Well, it's over here in this table over here. So we can find it. We have the problem table, and then we have the solution table. And so if you have a problem, right, there's an isomorphism that takes you from here to here. Because if it's a bijection, that means the map works both ways. You can go this way or that way. Okay. So we're going to be talking about that. So that is kind of the beginning of this section. That's the first subsection. Thank you for watching.